Hello friends, in today's video we are going to draw the isometric drawing of a simple component whose orthographic views, that is two-dimensional views, namely the front view, top view and left hand view are given. Friends, basically, whenever you want to draw either the isometric drawing or the isometric projection of a part or a component given to you, you have to check what are all the overall dimensions of that product or an object. Friends, you can see here, this has got a square shape. The top length and width are 50 mm each, and the height is also 50, and the end view you can see it is also having 50 by 50. That means it's a clear indication that the object we have got, for which we are required to draw the isometric drawing, is a cubical one, is a cubical block. So friends, what I do, the dimensions of the cube are 50 by 50 and height is 50. So friends, I am going to construct a box here having dimension length 50. So I will say here this is 50, this width is 50, height is also 50. So if you want you can show them also here to start with. This is 50 mm. Since this is isometric drawing, orthographic to isometric. So we have to take the actual dimensions of the solid. So this is 50 and this is also 50, that is the width is 50 and the height is also 50. So we have going to mark a cube in isometric drawing. So friends, now what is to be done? Let's see. In the front view, you see it as a square. In the top view, front view is, say we are looking from this direction. This is the front view here. This is the left hand view. We will say LEV or simply E, end view. And this is the top view. We will say T. So friends, in the front view, it is a square. In the top view, it is a square. In the end view, you can see that there is half that square, means half the other part of the square is removed. And I feel, and I am of the opinion, it is better to start from this in the left hand view. Friends, this line is represented by this last line here. So I will just write a line through this. This has got a height of 50 and the bottom is also 50. So I can just complete this left hand view part of that 50 by 50. And friends, this point is starting from here and ending here. So I have to join these two. That is, this portion of the solid is over. Now friends, if you want to see only this triangular shape here, so we have to have one more parallel or similar thing on the other end. So friends, in the front view, this is visible. So I will just mark that by a visible line. And here, since these 4 points, 1, 2, 3 and 4 are seen as a single line. So there should be one more line parallel to this from this corner. So friends, I am going to draw one more line parallel from there. And after that, friends, you can see here, this top portion is this edge. Or I can just simply join these two corners to give the correct shape of that. And friends, if you see from the front, and this surface, whatever you got, is this line. This line and the last line, they form this surface. And friends, if you see from the front, you can see this baseline is the baseline, and this point appears as if it is here. So this point is this one. Similarly, this point, the corner, appears as if it is here. So I have got that on the left hand. So This surface, whatever I have shown here, is the front view which appears as a square. And similarly, friends, if you see from the top, this line is this. This is the top line and this is the bottom line. And again, friends, on the same principle, this point when you see from the top, it appears as if it is here. Or just imagine. Similarly, this point appears as if it is here. So friends, you are going to have one more line like this. So friends, after completing these projections, there is the isometric drawing of the solid, wherein we have drawn this figure using the actual dimensions given in the orthographic projection. This is how we are going to get. And to make it little meaningful and wherein you'll be able to see or visualize this, I am going to remove all these construction lines one by one so that you will have a better picture or better visualization of this solid. This is how it looks, friends. So I will remove these dimensions because in orthographic projections or in isometric projections or isometric drawing, we do not show any of the dimensions, we do not show any of the hidden lines, etc. So after removing all these, friends, I will show you how the object looks. And friend, this is how it will look. And I'll just give a finishing touch because this width is looking little more. So let me join that by a line parallel to that. I think this is looking better. Friends, this is what the actual object is. So you can see here, this is 50. This side is also 50. 50 by 50. In the end view, this is 50 by 50. 50 and this is 50. That's what you are seeing. And this surface or this rectangular face you see here is representing this line. So this has got 4 points. 1, 2, 3 and 4 corners are there. And we have removed all the construction lines from here because that's a convention followed in all isometric drawing or isometric projection. Friends, you have to be very familiar both conversion of orthographic view to isometric drawing or isometric projection, or given the isometric drawing or projection of a component, you should be able to obtain the orthographic views, that is the two-dimensional views of that given solid. Friends, I hope the presentation was interesting and you are able to grasp the procedure followed to obtain the isometric drawing whose orthographic views are as shown in the figure. Friends, please go through the complete video, and if you like this video, do share with all your friends without fail. Thank you for watching my YouTube day.